this is a gentleman that designed this device himself. We have Paul Palaskis here to tell us about his not laser, a lathe engraver. So Paul, over to you.
Just one slight correction. I'm actually further away than Richmond. So I'm in Silver Spring, Maryland. So it's a little bit further. It was a bit of a haul. No, that's fine. Well, thanks everybody. I drop the microphone. And I am a university professor, so I'm used to like having to project my voice. So you probably have to turn the mic down at some point when I start yelling at you. I'm really happy to be here. Thank you very much for the invitation. And I think this is going to be something that's a little bit different. Again, I'm not going to be doing any turning, but we're going to look at embellishing. And it's embellishing that's done a different way. And I am going to be talking about CNC. Some people have an immediate reaction as soon as you say CNC, and they're like, no, it makes things for you. And I hope that I can convince you that that's not the case, that there's still a lot that's involved in this. What this is a tool, and it's a tool that can do quite a number of things, and I'm going to try to go through a variety of those things and show you what it can do. And just a little bit about my motivation for doing this. I got into 3D printing a long time ago, and that got me interested in motion systems. And so pretty much any time I would see something, I would think about a motion system. And then when the pandemic hit, I needed a new hobby, so I picked up wood turning. And immediately when I got the first little lathe, I was thinking, well, could I automate anything on this? And I built a little laser that could, I did what everybody does, and I did pens early on. And so I turned a few pens, and I thought, well, can I laser engrave on pens? And I built a little contraption to be able to do that. And I laser engraved 2 pens, and then I turned a bowl, and then I've never turned a single pen since. So I scrapped that idea, and then ultimately when I got a larger lathe, I kept thinking about this idea of how could I do this, and this is what I've come up with. Now you'll notice it's not on a lathe, but I have a stand, something that's in place of the lathe itself. So this is a standalone platform. The whole contraption can be mounted on a lathe. You just have to make sure that you get the tool on center. So if you want to take this whole piece off here, it can be bolted onto a lathe, and you just use some standoffs to make sure that you get it at the right height. I call it the lathe engraver again because it's not something that's meant for hogging out material. It's not going to make a bowl for you. It's just going to do embellishment work. It is a 4-axis CNC, and I'm not going to go a lot into CNC here. I'll mention a few things, but I'm not going to go into any of the details unless you want to hear about them. So if you have questions at any time, please feel free to stop me and ask. It's a 4-axis CNC, so we have an X-axis that's moving the tool back and forth this way. We have a Z-axis that's moving the tool this way. We have a rotational axis. This is our A-axis, and then we have a B-axis, which we can actually rotate the tool. And this is one of the, this ability to rotate the tool is what I think really makes this machine something that is specific in terms of wood turning. I mean, it allows you to actually do things with bowls as opposed to if you had a little hobby CNC and you put a rotary axis on it, you don't have that ability to rotate the tool. And I think you'll see how that's going to be pretty powerful. If we can go to the software view real quick, I'm going to be showing this. I'll be showing the software fairly regularly here because it actually shows how we control things. And it's relatively straightforward. You have to have a computer to do this, but all the controls happen at the computer. And a lot of people are concerned with, well, I don't know how to program anything. And what I'm going to show you is that you don't have to really do any programming. You have to know what the machine's trying to do, and you have to be able to enter some parameters. And if you enter those parameters, then you can at least figure out how to do some interesting things with this. So this is what we'll be looking at with software. I can move the axes around. I can either click the buttons here, or I can just use arrow keys. So there's hotkeys to be able to move all of these things around. So we'll be doing that a little bit. And in all of the examples that I'm going to show you, I'm going to be mounting things on recesses just because I think it's overall it's going to be easier to see. So the first thing that I'm going to do is one of the things that I envisioned for this machine was when you're starting off, you're using a lot of not particularly good pieces of wood. At least that's what I did. I picked things out of the firewood pile, and it had lots of cracks and things. So I wanted to be able to do repairs on those cracks with Pewa, butterflies, bow ties, whatever you want to call them. And so the earliest thing that I did was to figure out how to do that. So I'll mount this piece up, and this is a piece of yellow wood here. And I don't know if I'll rotate it around so you can see this. But if you go to the top camera view, you'll see that there's a couple of cracks in this. And so what I can do in this case is I can decide as I'm twice turning this, for example, I've got some cracks here and I want to be able to put some recesses for those that I can put things into. So I'll mark the position on those, and the piece of information that I need is I need to know the diameter of where I'm going to make a cut on this. So I just scribe a line around this when it's still on the lathe, come in with a large pair of calipers, touch off on the lines, and you can then, I have a little ruler here, and then just measure this. Now, one of the things with this, which hopefully it won't make anybody too upset, everything's in metric. So all the measurements that I do are in millimeters, and there's a couple of reasons for that. First, I'm a scientist, so I use the metric system on a daily basis. And second, it's a lot easier to do the coding when you just have to enter decimals and you don't have to do a whole bunch of fractions. So it just makes it a lot easier. So I can measure these positions here, and in this case I've got two spots that I've measured, and I've written on here so that I don't have to actually do this, that I have 168 millimeters for diameter and I have 185 millimeters for the diameter on this. Now, one of the things that this lets you do is if you've ever done any CNC work before, you have two things that you have. You have CAD, so you make a drawing of some type or a three-dimensional model. It can be either two-dimensional, three-dimensional. And then you have CAM, which is computer-aided manufacturing, which is what actually tells the machine where it's actually going to move. What are the tool paths that it's going to follow? And so what I wanted to do with this is make this as simple as possible. If you've ever done any CNC work before and you have some CAM package that you like, you can use that. Because what this will do is it'll take that two-dimensional, well, three-dimensional, because typically you have X, Y, and then Z, which plunges in. You can take those, and we can use those directly. You make some modifications, knowing what that diameter is, and we can use that code directly. There doesn't have to be anything special that you have for having this additional ability to rotate the tool. So one thing that I'll do before I actually proceed any further, because I didn't do this when I started, is that I want to make sure that I, okay. And now nothing's happening. That's always interesting. Oh, I clicked a button, sorry. I'm going to make sure that I set this tool right here. I'm going to have that be zeroed. So the tool itself is going to be perpendicular or parallel with this axis here. And then I'm going to set that 0 position. So what I can do is I can simply, I'm going to be working on this side now. I'm going to rotate this around until I get to be perpendicular to this cut site that I'm going to have on this piece. And so you have to eyeball this.
What do you have exactly cutting the wood? Is that a bit?
Yes. This is a 2-flute 3/32, so that's 2.38 millimeter end mill. So this is a carbide end mill that's going to be on here.
Upcut?
This is an upcut bit, yeah, in this case. For some operations, downcut, it's going to work better. And then I can rotate this around to that site. Now, the one thing with this crack that I have here is that the crack is not straight up and down, it's at an angle. So I want to also be able to adjust the angle of this cut that I'm going to make. So I'm going to position this on the site, and I'm going to set this at the 0 point, oops, wrong key. And this table's just a little bit high for me, so I got to get on my tiptoes here. All right, that'll be good. And I already kind of estimated what that angle is. So what I can do is I can go, and this is, by the way, this is all software that I've written that essentially goes with this whole machine, is that I can enter what that starting diameter is. In this case, this was 168 millimeters. And then I have this ability to take a rotation angle. I say, okay, I think this is a particular rotation angle, and I can gauge that by picking out one of my template files. So these templates are all things that are already pre-generated, or you can make your own template files. But I've got a whole bunch of them that are already created. And you pick these, and if we go to the software view real quick, you'll see here that I've got the ability to see what that rotation angle would be. And in this case, it looks like it's about 40 degrees, so I'd put in 40 degrees right here. And all these other things are sort of things that you can adjust. You don't have to. One of the things that we always have to have on here is flat pockets, because what we're going to do is we're going to take one of these and we're going to put it into that. But if you think about what happens if you have a round piece and you're rotating it while you cut, all you do is you start with a larger diameter and you make a smaller diameter. So one of the things that the software also does is if you check that box, it'll actually, as you go to the middle, it's going to actually cut slightly deeper to make that pocket flat across the bottom. So we're going to go to that position, and then we've selected the file that we want. This is this small Pewa. That's what I have here. It says the bit size and the depth of the cut that we're going to make. And then we click this write G-code right here, and it'll write that G-code for us. Now, one other thing that we have to do is that this is now our 0 position. So we have to make sure that we zero those axes because it's going to be right on the center position. So I'm going to click this XZA, and I click 0. And you'll notice now that all of these are 0, but our B axis, which is our rotation of the tool, has a particular angle. And it's knowing what that angle is that as it's sending the coordinates from the machine to the control box, it's actually adjusting them. So we could make that cut here, we could make that cut here. At any of those angles, we can cut the exact same pocket starting with the same template file. So if you've used like the Big Island engraving system to do any of these things where you put a router template, you can imagine it's the same kind of idea. It's just that our templates, infinite number of templates that you can have because you can design your own things to put on here, and you can do this anywhere on the bowl, and you can do them very fast. If you mark the positions out, and once you're adept at driving the machine around, you can do it pretty quickly. So one thing that I'll need to do is make sure that the router is going to turn on. So I'm zeroed at that position. I'm going to turn it down a little bit, try not to make it quite as loud. And now, when I click that write G-code file, it created this file. So our diameter was 168 millimeters. Our rotation was 40 degrees. And this is saying that we're at origin at the center. So now, if I click start here, I'll just make sure that I've zeroed everything. Yep. And I can actually limit the depth of the cut. It's going to do a 6 millimeter cut, but if I wanted to make it less than that, I could put in a value there and it would decrease how deep it's going to cut. And I'll just go ahead and do the full 6 millimeters. I don't know if I can kind of swing this one out here a little bit, or maybe that from that camera you can get a better. I'll rotate it around once it's done. So if I was going to make this other cut, I could just go to that next position, write the next file, and just rotate everything around and then start the next one. So I've tried to time myself, and I can do about like 22 of these in 30 minutes if I'm on top of my game that day. So if we go to the top view here, you can see the pocket that it's made there. And which should be able to, and these I cut on just a 3-axis CNC, but you can actually use the machine to cut these as well. You would just use a piece of flat stock across here. You do the same thing, measure the diameter, and it's a nice tight fit for that. So I'll go ahead and take this off. And you can wiggle it around and pass it around. I won't do any more than that. But the concept of that, the idea that we can rotate the tool and we can put it at any diameter we want and make any design we want, opens up a whole realm of possibilities for doing different types of engraving. So you don't have to do things that are strictly repair work. You can do things where you're doing it decoratively. So again, that it took me like, I don't know, somewhere around an hour or so to cut all the pockets for doing that. It probably took me longer actually to cut out the inserts on the CNC. Yeah.
So you insert those all there above this flush. You turn them.
That's right. So I would typically, I would start doing a twice turning. I would get it to sort of close to the point that I want, make all the cuts, put all the inserts in, and then turn it down. You can do even more complicated things. You're not limited to just a router, so you can attach a laser to this as well, and you can start doing things along the rim. So the whole idea of taking something where you have a two-dimensional design, if you know what the diameter is where you're making that cut, you know where the circumference is because you can just multiply it by pi, and now you make a design that is linear in that length of that circumference, and it'll wrap around. And so there's an example of doing laser cuts. And I'll do one of those. I think I'll have enough time, so I'll show you how that works.
So do you have a dedicated computer for that?
Yeah, I do. I keep this laptop, right next to this thing. So that's the other thing is I used to bolt this onto my lathe every time, because I used to work in a very small space. And so I used to bolt this thing onto my lathe every time I wanted to use it. And it's not that it took a long time to do. You would have to have this motor here would sit on another piece of aluminum extrusion. You have a pulley that would sit behind the chuck, and you bolt it onto the lathe that way. This just speeds things up because I can take the chuck off of my lathe, I can bring it over here, put it on, cut a pocket, take it back to the lathe immediately. So for what we're going to do for this one is just cut a design that goes all the way around. I'm going to do something that's very simple. I am going to cut it a little bit deeper and a little bit faster than I normally would, just so that it doesn't take as much time. But you'll see that the process is going to be essentially exactly the same. This is the design that I'm going to cut in here. So I've measured the diameter, so I have a center line here. It's 170 millimeters. You multiply that by pi, that's 534 millimeters. So this design, if we can go to the computer real quick, this design I've made is exactly 534 millimeters. And I take that and I have to make that as a template. And so there's lots of different ways to do that. This is a free piece of software called Kirimoto, where I've taken that design and I've put that in here, and I can then essentially say just follow the path and cut this. It'll export that as a G-code file. I take that, I can directly upload that here into these templates. That's what this file is right here. And then when I go to this software here, I enter that starting diameter, which was 170. I don't want any rotation on this. And in this case, I need to make sure I turn these flat pockets off. Because if it tries to do flat pockets in this case, actually, you can pull that out, you might be able to see with that small one that it does cut it flat across the bottom. But we don't want that for this. We want this to be going all the way around. So now I'll just go ahead and write that file. And I'm going to drive this into position. So not quite there. There, that looks pretty good. I'm going to 0 that because this is now our origin position that we have here. And this is just the file that we wrote. So our diameter 170, our rotation is 0 in this case. And this should take about 5 minutes. So if you have any questions while this is going. I didn't. I did the standard error, which is that I forgot to 0 it. At least I think, no, wait, I did 0 it. I might have. Oh, no. In my haste, I have made a mistake. Z anchor should be top. That should work. All right. For the sake of time, I'm just going to skip that one. I'll show you examples of what it can do when you have things set up correctly, and you're not doing a demo, because it always works when you're not doing the demo. So in the same way that we did those other ones, in this case, this is just multiple patterns done 5 times that are offset. And again, the tool is just being set at different orientations for each of these in order to be able to do that type of pattern.
The circumference of each of these is different.
Yes, they're different.
Smaller each time.
That's
so
right.
It automatically adjusts the width of these?
It doesn't. So in that particular case, that was probably the most complex piece that I've done this way, because I had to adjust the small pieces stay the same, and the larger pieces in that weave get smaller. So I had to adjust that for each circumference. I measured the 5 different diameters that I was going to use, and then I knew how much I had to adjust each of those as I was going through.
So just like that one had one circumference was one measurement, but the other side is a different.
Right, but you're always measuring in the middle.
Okay.
So so as long as your origin that you set is being at the middle, then it's going to be able to do that correctly.
And you always use the same bit? You don't anything larger?
You can use different size bits. It just depends on what the operation is that you're going to do.
Okay.
So
Something like this, would you use that, or?
yeah, so I would actually, for something like that, I would use a ball nose end mill as opposed to a flat end mill, because for doing this, it actually is doing contouring, so it would actually be going back and forth to contour those. And then they all get sanded later, which obviously is one of the things that takes the most amount of time, no matter what.
Is the router speed critical?
Not really. This router is actually probably way too fast for most things. So I keep it pretty low. We can do things like this. So, if you cut a pattern, what do you do with it? Well, one thing that you can do is you could fill it with resin. And in this particular case, if you'll notice, if you hold it up, it's actually going all the way through. So this is probably, there's no other way to do this. And this was done with a single cut. So the idea, sorry, I'm holding it off camera. That's probably not a wise thing to do. Yeah, so it was all done on the outside. It was just cut deep enough in this case that once it was, those cuts were made, I could pour the resin in there and then come back through and turn it through the inside to be able to see what's going through the interior. Now the thing that you could do that a lot of ways, but one of the things that you can do with the machine that makes that a lot easier is if you know the shape of the bowl. So this is the same pattern, different bowl. So this is effectively how this was done. But in this case, I know the shape of the bowl, and I can use the machine to get the shape of the bowl, so I can go back over to my 3D printer, and I can print a shell that I seal the bottom of this, and now I've got essentially a perfect mask for the bowl that I could use to pour the resin in, and then turn the inside out. Actually, I found I had to do that. Turn the inside out and then come back around and turn everything off. And this is just a single thin 3D print, so that you just turn that away, and you're left with a result like what you see there.
PLA or PET-G?
This is PET-G. I like PET-G, particularly for doing these, because I can use the clear and I can print it very, very hot, like 280 C, and it's almost clear. You can see through it, so you can definitely tell how far you filled with your resin when you're putting it through.
Sir, would I have to go down to the bank and get me a loan to put this together?
No. You wouldn't have to go to, a lot cheaper than any lathe that you buy. Well, maybe not entirely true, but it's not expensive. So everything you see here, so including the platform, except for the tools, I don't sell any of the tools. It's about $1,400. And that comes as a kit that you put together, and that includes the electronics and just not the tools, because I don't want to have to do support for somebody else's routers and somebody else's lasers. I can handle it for my stuff. But
What size steppers do you use?
these are NEMA 23 stepper motors. I can't remember what the Newton meter ratings on them are, but I use a slightly larger one for the A rotational axis than for the linear axis. And I don't really have a problem with that. It uses silent stepper drivers, so they're TMC 2209s or TMC 5160s. So they got, what's that? So there is backlash in the lead screws. There's always going to be backlash in the lead screws. I use anti-backlash nuts, and also there is backlash compensation in the firmware of the board itself. So you can measure the backlash, and it'll compensate for that backlash. So how do we get that shape or that profile of this? We have that written into the software itself. So I can actually just do it with this one, since I didn't cut on it. I'm going to move this off a little bit. So this is a 3D touch probe used pretty often on CNC machines. And this will fit right into the router, so we don't even have to take anything else off of this. Has a connector here. And the one thing I like to do is make sure that it actually is triggering. So if you see on the screen here, a little P shows up whenever I touch that, so we know that it's actually functional. What we can do is we need to know, well, I'll go to the other piece of software here. So this is scanning. And again, this is all you're entering is parameters. And so the things that I need to know is how far I want to actually probe on this. So I'm going to just eyeball that and say we're going to do about 80 millimeters on this. We don't actually need to know the diameter in this case, because we're just going to be probing the outside surface. If we wanted to actually make an STL file or a three-dimensional file, like for what I did there, you would need to know what the diameter is. So you could just come in with your calipers and measure the diameter at the rim, which would be the first spot that we're actually going to probe. So I'm going to put this information in. So our reference diameter doesn't matter what it is. I'll just put a value here. So we're going to do 80 millimeters. Our scan increments, we'll do 5 millimeter increments. We'll pull off 2 millimeters between these, and we can give this a scan. This is some maple. One of the options that we have for this is, well, you've all worked with wood. Wood moves, and it doesn't stay round. And so sometimes when you're doing operations, you're going to have an oval bowl. And so you can actually do ovality scans, so you can measure at multiple places along this, and it has the ability to then compensate for the ovality of your piece for some of the operations that you'd have. I'm not going to do that here, but I'm going to move the tool right on to the end, the probe. So that'll be good there. I'll zero that, and I'll go back here, make sure we're going positive, 80, and we click Start Scan.
So does the software control the speed of the bowl?
This,
You're getting down to the short side of it? I mean, does it control the motor that's turning the bowl?
it does, it does. So this motor over here is always controlling the spindle itself. So that's controlling that. Yep. And if you go to the software view real quick, you'll see that as it's actually doing this, it's actually showing you in real time the profile of that bowl.
Do you have trouble sleeping at night?
Yes, I do. I went one too far here, so I'm touching off the 10 in there, but that's fine. So now we have a profile of this, and if we had, for example, checked this create STL, it would have made that three-dimensional file that we could have done other things with. But there are other things that we can do with this profile. And I actually have a whole setup of things that can be done once we know the profile of the bowl. And I don't know, how many people here have done or do basket illusion? No, nobody's up for it. Oh, you did some? Yeah, it's usually people like, oh, that's a little bit too much work, too much effort to burn all those lines. But if you hook up the laser, actually, I don't know where that one went. Is that over there? Yeah. If you hook up the laser and you know the profile of the bowl, you can do a scan, you can put in your beads, and then you can say, okay, I want to start burning at this spot, and I want to end burning at this spot, and I want to do that 200 times at this power. And again, these are all parameters that you put in, and my beads are not particularly nice on this, but it'll go through and it'll just rotate the bowl, make your bead, rotate, make your line, and it'll do that around the whole thing. And so to do this is 200. That's not a very long segment, but this took less than 20 minutes to do. Versus if...
Your question on this one.
Sure.
When you actually did all of the cutting, it was on the outside?
All the cutting was on the
It
outside.
was pretty thick, right?
Yeah. Mm-hmm.
And then after that, you turned it down to get the light through.
That's right, yep. So I'll give you, I'm going to show you examples for some of the things you can do once you know what the profile of the bowl is, and I'll just run through one thing on this. But that first example is if we were doing lasers here, and let me bring up that profile. So this was our maple. So that's the profile of the piece that we just scanned. And I could, for example, say, okay, I want the max limit here, that's where I want to actually make the lasers lines, and then I want to go to here. And you could do that, and that would tell you that that's the length that you're going to make them. We have other things that we can do. One of these is doing fluting. So the idea of fluting is something along the lines of this. So this is fluted on both the inside and the outside. This is in the style of Pat Wisniewski, who's up in Delaware. And this is essentially just making a cut, and you get to determine how many segments you're going to make of those cuts. And you can also put an arbitrary rotation into that cut that you're making. And you get to set the depth of the cut. So in this case, you make it not too thick, but thick enough that you can make a cut on both the inside and the outside to get this ribbon edge sort of platter look. Now this one does have a lot of these things I'm giving you are unfinished, so that you can get a sense for what they look like if they're, that one has only been sanded in the cuts, so
swirling this way, you've got holes through it. How did you see it in a book or?
As I said, Pat Wisniewski.
Is that what it is?
Yeah.
He's thinking about these things.
Pat Wisniewski. So Harvey, he learned from Harvey Fine, who does a lot of this kind of thing. But this was sort of Pat's idea, and Pat has one of these, but he does it with a totally different setup. But I wanted to see if I could sort of redo one of his designs using this machine. And I don't know that he's done it yet, but he says it's a lot easier to use this.
One groove, is that the way out? or-
That was me messing up on the very first cut on that side.
Okay.
Yeah. I have a lot of those, so
Well, that's okay. I mean, you're doing really good.
I would say that I've probably, I've messed up probably more things than I've made nice things, because it's development too. I'm trying to figure out how to do all of these various things.
On the inside. I just see it on the outside.
Yeah. Well, I should have. I should have. So it was. I didn't know if I had to do which direction I had to move to do the rotation,
Yeah,
and so that's where I made the mistake.
yeah, because that is kind of going against the mold.
So I'm going to put a larger end mill on here. So I don't know if somebody was asking about doing larger end mills. This is a ball nose end mill, which is fine. I'll just use that one. One of the things that we do have to know is that because we're going to be following a profile, the B-axis now, where it was fixed before in what we did, it's now going to actually rotate. And it's going to follow that profile. So we actually need to know what the length of the tool is, because we need to know the distance from the center of this, from the surface of this to the center of rotation. So that's what I'm going to do now. And I probably should have... I'll have to do some estimating because I didn't bring my cheat sheet. So this is about about 60 millimeters. So that's going to be 135 plus 7, 142. So I'm going to, we don't need the diameter reference for this. I'm going to do, let's say, just something simple with 5 segments. Our rotation, I said, was going to be 142. What we have to do, though, is we have to know what our zero position is. And so in this case, we have it in our profile. It says 0, 0. So that's where we need to move the tool to. So and I do want to make sure that that's good. Now we would want to know if this is the correct position. Is this really where we want that tool? Is that really where we want the laser to be? So one of the things that we can do in this view is we can set a target. So I can set this target here at the same spot as my max position. So I put that little marker there. And as long as I have this rotation center set, I can say go to target. And you can see what it'll do is it'll back it off. It's going to rotate the tool. So that's the angle that it should be at that position. And then it's going to move in, and we can determine if we're at the right spot. And I'm just a hair off. I'm about 1 millimeter off on this. So I either have this length a little bit off, or the rotation of this B is off a little bit. So I'm going to reset the position. So I'm going to set the target back here. And about 1 degree over should get me there.
Now, are you measuring where the lines are on the center of your bit or on the
Center of the bit.
center of the bit?
Yeah. Mm-hmm. And we'll check that again. So I'll go here, I'll set my target close to this spot again. And this should get it, I'll either be touching or I'll be very, very close. Yeah, just touching on there now. So I'm going to make this a little bit longer. So I'm going to set my max position. We'll go to about here. And I'm going to crank this up. So this is going to go fast. You have the ability of also setting a lead in and lead out. So it would actually make a more shallow cut as it's going in and then bring the cut out so that you don't have something that's plunging in directly. I'm not going to worry about that in this case. And I'm going to make this, we'll do 2 millimeters. We'll just do one, and then I'm just going to do 5 segments. Now, typically what I do is if I wanted to do a fluting like that, I would measure the circumference here and determine the diameter of my bit and to see how much spacing I can have to be able to go around that. But I'm just going to, I should be plenty safe in the spot here. And once we have all of that information set, we hit write job, and it'll go through and it'll write all of those, and it'll write us a file that'll show up here in a second. So here we're doing fluting. We have 5 segments. Oh, you know what? I'll put some rotation in there. Let's do a 25 degree rotation. Rewrite that. So there now it has a 25 degree rotation. So each of these, as it's cutting the flute, it's going to rotate this 25 degrees. Back that off a little bit. Yes. Yeah.
I remember that bowl.
Oh, this.
Yes. I saw him. He had a lot of people that would use all
Quite a few. One of the things that I've added to this recently is that, doing a rotation like that, it's kind of neat. You can do various things, but it's a lot more fun if you could make your own pattern. And so now you can actually follow if you can draw a pattern as a scalar vector graphics file, an SVG file, and you can say, I want these flutes to follow that pattern. And so you could do like sort of a multi-curve or sort of a wave pattern or something. So I use almost all free software for everything. And so to make that pattern, I use something called Inkscape. And so it's free. There's a little learning curve to figure out how to use it, but you're essentially making just horizontal lines. So it ends up being not too difficult to do. So I realize that's probably not particularly interesting just doing a 5 little flutes like that, but you get the idea of you could set multiple patterns as well, right? You could do 5, and then if I was to offset it by the appropriate number of degrees, I could do smaller ones in between. So you can do lots of different patterns that way. One of the other things that we can do once we have the profile, if I go back to the software here, is this thing that we call wrapping. So a lot like what I showed you before, where you can take a design that is going to be on a 2-dimensional design, you can take that two-dimensional design and you can actually wrap it onto the surface of your bowl. And that one takes some time to do. This is one example of doing that. So this was done in a slightly different way but I mean, I could do that now with fluting because I could follow that pattern, but in this particular case, it was done by wrapping a design on there. And this one is another case where, sorry, I feel like I'm caged in, so that's why I keep moving outside of my cage, is being able to do something like this. So this actually started as a three-dimensional file, and I generated the G code for this like you would do if you had a hobby CNC machine to be able to do this contour, and then that's actually wrapped onto this. So I left a strip here, and I can tell it how many I wanted to do. So I think I said, do 8 of these and put it on, and it took a while to do all of the cutting. And I've sanded in between, but I haven't sanded them themselves, so you can see what the finish looked like for that. That's not something that I'm not all that interested in doing those kinds of patterns. I prefer things that are done more directly on the machine itself. And yeah, go ahead. Oh, I thought you had a question. The last one, which is what I've probably been using this the most for, is the idea of making facets. So if you know what the diameter is of your piece, you can imagine that if you have a circle, that you can inscribe any shape inside that circle. So if you wanted to put a hexagon, right, you could put a hexagon inside that. You could put a triangle inside that circle. And if you imagine now, if I just took whatever, let's say I had 6 sides on here, and I took those 6 sides and I cut off to make those flat, that would be faceted. And so that's why I call it facets. You could cut those on the exterior or the interior of a bowl doing that. And so this is using, again, the same sort of setup that I just talked about. I can put facets onto a piece. In any number that you want, you can also do curvature to the facets. And if you think about what happens with a facet in this kind of case, it's making the most shallow cuts on the outside, and then as it gets towards the center, it's making deeper cuts to make that facet. Well, one thing you can do is you can just reverse that order. If you make the cuts deepest on the outside and more shallow in the middle, rather than getting a facet, you get a scallop. And so I've been doing quite a lot of these scallopings. So this is unfinished entirely, so you can see what that looks like. This has arbitrary rotation in it, so I don't know how many degrees. And there's one that's actually finished. So.
And when you set up the machine to do one of these, you save it off? It saves on and you cut another bowl, basically the same dimensions and whatever?
If you cut another bowl that was the exact same dimensions. So,
Exactly, close.
yeah, you don't save it. So you have to go back and you have to rescan that profile for whatever bowl that you're going to use, because it really needs to be exact, particularly in a case where I mentioned where if you've got ovality, right? You want your cuts to be all the same depth, particularly in like the fluting type of things there. You want those cuts to be right at a particular depth. So you need to actually do that for each bowl. Yeah, so I thought I had a couple more.
Hardware and the software?
Yes, I don't charge anything for software. I don't believe anybody should pay anything for software ever. So the software I give away for free. And for the $1,400, it's the kit for the platform and what's sort of the cross slide for this.
So how do you learn how to use all of it?
So practice, right? Like well, yeah, I do have videos on YouTube. I have some tutorial videos on how to use it, but a lot of it is just getting in there and learning what it's actually doing. There's a user group, so there's about 20 people that have these now, and so everybody's sort of at different stages in learning. But
You start out with cheap bits because you're gonna break them?
you know what? Breaking bits hasn't really been a problem for me. I mean, I have plunged a lot into things, but fortunately, like most of the time, I see what's happening and I hit the stop button. So I haven't broken a lot of bits. But yeah, there's some additional cost that you're always going to have anytime you get into it. Yes?
After you mount this on a lathe,
Yes, the lathe is the A-axis if you mount it on a lathe.
How do you control the motor and have it step then?
You use the motor, it's the same motor that's here, but typically you'll mount it on another piece of aluminum extrusion here
You're
with,
just using the lathe bed.
you're using the lathe bed, yeah.
You're not using the lathe motor.
Not the lathe motor, yes, right. I misinterpreted your question, yeah. You still use the stepper motor here in order to drive that, because you need to have controlled motion, yeah. Right, so facets. One thing that it can do that I won't demonstrate here, it'll cut threads. So if you're making boxes and you want to do threading, you can put on something like, you can buy a thread mill, or what I've been using is a 16th-inch slot cutter to cut essentially square threads. And it's parameterized just like everything else. So you put in the length of threads that you want to cut, the pitch. Again, everything's in millimeter, but you can convert it to TPI if you want. You put the depth of the threads. You can put the number of passes that it takes to get there. You set the feed rate, and you can even do multi-start threads. So if you wanted to do 2-start or 3-start threads, it'll do that. And again, you just enter all this information, click if you want external or internal threads, click write threads, and it'll write all the code that you need to be able to do those threading operations. Yeah.
So you cut to this part, but then in between, are you cutting that too, or do you have to go back and?
No, it's cutting that as well. So the design that I used in that case was sort of a flat with that acorn leaf thing in the middle there. So it cut almost all of that out of that rim that was there, that was left. And again, I've only sanded in between those. I didn't actually sand anything else. So that's, I think one of the things is that I've tried to make this have as many functions as possible to make it worthwhile for people to get, because a lot of these things you can't do any other way, but you could buy a threading jig. Like if you bought the Simon Hope threading jig, or the Baxter threading jig, it's a significant investment still, and you only get 1 or 2 TPIs that you have, depending on whatever the crank is. Here you've got whatever TPI that you want, because you just enter it as a parameter, and it drives it. So the idea is versatility. Well, I mean, you can just do the conversion. It's not that hard. 2.54. That's all you got to remember, right? Yeah. So, but that's a large portion of it is making it a versatile tool, and I think there's a lot of other applications that people can have. A lot of people do additional decorating, but if you're going to do some of those types of those faceting operations, it kind of makes a neat canvas for you to come in with doing your pyro or something else, so you can get some different shapes, even if you're doing other types of embellishment work on these.
Doing spindles?
Yeah, you can do spindles. So I do have, and I won't show that, but I got a request from somebody that they said, I want to be able to do some very specific types of shapes, and I want to do them over and again. I want them to be very consistent. So I wrote a piece of software, which I haven't released yet or anything, but basically you tell it what the diameter of your spindle is, you draw a profile of the outside of what you want, and it'll go through and do the tool paths, and it'll just cut out a shape that you want. To me, that's kind of CNC lathe work, which is not that interesting to me, but I had a request for it. So
What happens when you want to do something inside the bowl?
the limitation that you have is, can your tool reach there? So that becomes the hardest part, and I don't know where the faceted one, or the for doing the flutes on the inside and the outside, that does become a concern. How far can you actually reach down in there with your tool before the rim hits the machine? So you have to watch out for that. So it's always easier to make them flatter than deeper for something like that.
You run into the problem with chatter out on the edges very much?
Yeah, those. So I don't know if you noticed when this one was being cut, it started at the back, so the smallest diameter, and it worked toward the largest diameter. The reason for that is, anytime I would have a relatively thin sort of platter or bowl, and you plunge at the front, you get that chatter. So if you start here and work that way out, it's a little bit of cleaner cut than doing it the other way. Yeah. So I don't know how we're doing on time. We're doing okay, I guess. I've tried to add versatility to this, and when I was at the AAW meeting last summer, I talked with a few people who were members of Ornamental Turners International. So I don't know if there are any ornamental turners in this group, but I think probably a lot of people have heard of a rose engine lathe, and they probably said, I can't afford a rose engine lathe. So one of my challenges last August was to see if I could replicate the features of a rose engine lathe using this. So you don't need any specialized equipment to use just the machine to emulate what a rose engine will do. For those that don't know what a rose engine is, these go way back in ornamental turning, and you would have a rockable headstock. So the headstock itself would be able to rock back and forth, and that rocking would be controlled by something like you'd have on here, which would be a rosette. It would be a shape or a pattern, and then you'd have something that would be called a rubber that would be on this, and as everything was moving, it would be following this pattern, and depending on the divots in here, it would be rocking the headstock back and forth to make that pattern. And it makes really intricate and very, very cool designs, but again, costs. You can make some budget versions of it, but still cost a fair bit. So one of my goals was to make this be able to do rose engine-like things, and I didn't sleep a lot during that period of time because I was trying to figure out a lot of things. I'm not going to cut with this. I'm going to show you some of the other tools in a minute, but I'm just going to use a pen because I found that that's what ornamental turners do, is they use a pen instead of making cuts. Well, when they're demoing things. So I'm going to pull this off. And so this camera is going to be the one that's most useful for this. I'm going to move this a little bit. Yeah, sure. You want to do that? You want to do that now, and then I can set this up, and then yeah. All right, we're going to do a 5-minute break, and then I'll have this ready to go, and I'll show you ornamental things.
That sounds about right.
Thank you.
Quick thing for the folks online, can you repeat the questions I'm going to ask?
Sure. Yeah. I'm just setting the actual 0 point here, so I know really where that is.
What control board do you use?
I'm using, actually a 3D printer board. Okay. It's a Fly. It's from a company called Mellow 3D, and I just got a good deal on them, so that's the main reason why I use that one. But it's an STM32 based board, so it's a 32-bit board. Running Gerbil Howe is the firmware, so. It'll run on any operating system. Yeah, it'll run on a Mac. It's slightly more complicated to get it set up on a Mac, but I have users that are doing. Oh yeah, for sure.
Do you have to have a specific router?
You don't have to have a specific router. It is kind of designed for this size. So this is it's a 65 millimeter router. I don't know what that is in inches. But Makita made a lot of people already have them because Makita made one that was very popular. The main thing is that whatever tool it is that you want, you just have to be able to get it on center. So, you have little spacers or whatever you need to be able to get your tool where you want it.
What's this?
This is a laser.
It's a laser?
Yeah. So you can hook this laser up directly, and if you like, there was, I think I had a couple of designs. Like these lines are burned with the laser.
Yeah. Oh, that was, oh,
Yeah.
cool.
I don't hook up the laser during demos because I don't want to put any eyes out.
Yeah, gotcha. Wait, we all gotta wear goggles.
Yeah, that would be a.
You said you have your own board that you printed, or
Oh, for the control board?
Yeah.
No, it's an off-the-shelf thing. There's nothing special about it.
Yeah.
It's just a 32-bit 3D printer board that will fit the motor
3D
drivers. Yeah.
that was what I heard you say something about it, and it wasn't following. That makes sense. I usually use the geckos.
Oh, okay.
I've made half a dozen different CNCs. Or converted them, I should say. Very nice. Nicely done.
Thanks. It's been fun. I wish. Sorry, for some reason I feel a little frazzled tonight, but
It's always tough getting the setup away from your own.
yeah. I still don't know why my other thing didn't work.
Now, this was all your creation?
No, this is a cam package. This is Kirimoto. So it'll do, it's actually like a complete cam package. It'll do, you can do FDM slicing, you do CNC, you can do SLA, it'll do laser, water jet stuff. So, but it's all free as well, so.
Cool. I'm fairly exclusively Fusion.
Yeah. What's going on with that?
Do you have any Goddard guys that do your stuff?
No, actually.
I'm up at Langley
Okay.
Research Center. We've got a few CNC guys up there.
I screwed something up when this has a lathe mode as well, so you can actually,
Just have it.
yeah, like if you want
Do
to do chess pieces or something, you can
Yeah.
set it up to do that. And I did that the other day because I wanted to see how it worked, and for whatever reason, it totally messed up my it's setting the. Oh, you know what I did? Did I do that?
I didn't coordinate. We could have brought you down for the Woodworkers Guild.
Oh, is that like a?
It's their sister organization.
Okay.
I'm in the Woodworkers Guild primarily, but I do audio video setups for these guys. They
Yeah.
call us flatboarders.
Oh,
I'll let you focus.
no, okay, now I know what it is.
I do have a
Yeah.
question. It's not how you cut this, how you managed to do that.
So you found the mistake. There's always has to be a mistake in
the
every
dimple?
piece.
I'm talking about
These
the,
guys.
the whole thing, how it was made and how it was colored.
It's epoxy.
It is epoxy.
Yeah, I don't remember what exactly I did with that, but what I did is I made a mistake in
Had a
the-
gap?
Yep, I had a gap, and so I was like, oh darn. Well, so I thought I thought I would make little hexagons that were spilling through the gap. I was going to do more of them, but then I was like, that's good enough. But that's actually, I made all the hexagons in a single file, and then I'd scan the profile of that, and then I wrapped that G code onto that to be able to come through that gap.
Because
So.
I'm starting to do some pattern carvings with ink and other things, so that's why I asked you that question.
Okay, yeah, I'm pretty sure that was just like epoxy with some mica powder or something.
Oops.
Yeah,
Oops.
there's always oopses.
I've thought about doing what he's done. I didn't think about doing what axis do you call the axis?
That's B.
B?
Yeah.
Never thought about doing the B axis on it. But I've thought about taking one of my mills and just plopping it in front of the lathe and then putting, a spindle.
So one of the neat things is if whatever board you're using, speaks like Gerbil G code, you can use this software for anything, right? So
That's what was going on in my mind. It was like, actually, that software
the, o-
probably get me there.
the only thing is that I don't know if you noticed in my the axes definitions are not the same as what you'd have for a CNC, well, for a lathe.
axis.
Right. So typically this would be the C axis, right? And then this would be the Z, and then this would be the X. And I have those switched for the main reason that when you're doing a design like in a normal CAM package, I want it to like correspond. So when the user's looking at that, they can say, okay, X is going this way. So I wanted X to stay that way with the bowl.
Lathe work is,
Yeah.
but it would be closer to an X, a fourth axis on a mill, right?
Yes. Yeah.
Other than you've got
The additional rotation. Yeah. Yeah.
What I was looking at.
Yeah, I'm ready.
Does the laser come with that too if you buy it?
No, the laser's separate. So it's about 75, 80
If I
bucks.
pulled the laser off my D1 X tool laser, would that work?
It probably would. Yeah, as long as you can mount it and get it on center. Yeah.
What wattage is that?
This is like the theoretical 40 watt, which is really like about a 5 watt laser, something like that.
That's what I got. It's 40, but
Yeah.
it's good.
It's 40 power draw, not optical output. So.
What I got, the X tool supposedly is actually 40 out, but they're using,
Oh, is it?
they're using 4.
Yeah, right. So that one is, yeah,
Using 4 lasers in there, combining them.
right.
Yeah, it makes a big difference. I started out with a 5 watt and it would engrave it. I cut 5/8. I was cutting actually 3/4 pine with it, one pass.
Wow. Yeah, that's the thing is,
Slow it down.
I'm only doing engraving work right with this, so it doesn't, you don't need a powerful laser.
I got a 5 watt laser. I got a 5 watt.
Yeah, that should work fine.
I can do this. My inside never is the same concentric to the outside. That happens all the time. I don't know.
So with the wiring, where you hook up that laser would be the same for any laser, or would be different for
Yeah, it's just the
just an on-off, right? Basically?
yeah, it's a PWM. Yeah, so that's output. I have a lead directly out there. They actually have a laser. It's listed as a laser output on the board, and the firmware. That's what I've used for this. So I
The board
do.
that comes with it actually already has a laser out on it.
It does, yeah. The only thing that is a little bit, will run off 24 volts because the power supply for this is 24 volts. A lot of lasers are 12 volt, and so you need to step down that 24
Mine's
volt.
24 volt, we had the
Okay.
40 watt, I think, because you had to have a different power supply with the 40 watt.
Ah, okay.
You did bigger-
Yeah, that would make sense. Yeah.
Yeah, I just got into 3D printing. I've got a CNC router, but I haven't always completely learned that.
Uh huh.
So this stuff's like 3 lasers.
Lots of tools. Yeah.
Lots of money.
Sure. But yeah, this has been.
I have all the stuff. This is probably as cheap as any of them.
Yeah.
If you update the software, is that made available?
Yeah, I update the software probably, well, it depends on, once a month at least. So I'm always adding new features, and people will find bugs and report them, and I come back and I fix them. So I probably have more fun doing the software than anything
Chuck
else.
doesn't come with it, right? Just
Chuck doesn't come with it, no.
had like 4.
Yeah.
The router doesn't come with it.
No.
What, how many motors you got on here?
There's 4 motors.
Okay.
It comes.
So those don't, you don't split them up?
No, the motors come with it.
Okay.
So just not the router or laser or, the accessories don't come with it, but everything to make it move around comes with the kit.
It comes for an 1 1/8 inch.
Yeah, 1.25 inches. Yeah, 8 TPI. Yeah. I'm sorry, what? No, it's not patented. No, it's actually, I made it an open source design. So if you wanted to go have them manufactured, go for it.
That's a lot of effort, a lot of great effort.
But for me, the effort was the fun part. So I'm not in it for making money.
Does it come assembled?
I will assemble it for you, but that costs more. So the kit is the standard way people have been getting it, because you also then learn how to put it together, and like something goes wrong, you can fix it. So, and a lot of that goes back to my 3D printing days, because that's how 3D printers used to be. Less so now, but all right, ready to go? Okay. All right, so thanks everybody for sticking with me here. The last thing that we're going to do, as I mentioned before the break, was that we're going to do some ornamental turning. And again, these are things that are going to mimic what you can do on a Rose engine lathe. What I've done is I've stuck a little pen inside the router now in a little holder, and I have a piece of paper so we can just draw the designs, and you can. We're going to do that. We're going to do spirographs. But that's actually not what a Rose engine does. So a Rose engine, you'll take a design, and these can be any designs, and for this case, you draw them. So you can draw them in lots of different ways, but they can come in as SVG files, something that looks like this. So this would be an 8-bump rosette, and normally on a Rose engine, that would be sitting here, and as you're following that profile on that, it would be rocking back and forth, and you make the pattern. But because we have control over these axes, we can do that exact same thing. Now, this is not completely novel. People have done this before. If you ever heard Bill Ohms, he was a well-known ornamental turner that did something like this. The thing that's different about this machine, and the way that I wanted to design it, was that you actually operate it like you would a Rose engine lathe. You don't, for all the other things I've showed you, you click write job or write file, and it now writes all the things, and then you press start, and it goes go. In this case, the way that someone would be working on a Rose engine lathe is that you start the rocking going back and forth, and then you control the cross slide. You determine how far you're going to cut, how far you're going to move in. And so that's what I've done with this machine. So I've opened up here, this is what you can do rocking. So rocking is rocking back and forth, what I've described. And it has a maximum radius and a minimum radius. So if I want to draw this exact pattern as we have it here, I need to set the radius. So right now, I've set right at the spindle, this Z is at 0. And so I'm going to move that to 25. Because if we go back here, that maximum radius was 25. I'm not going to worry about the 0.4 in this case. So now I can simply click, I can set the RPM. I'm going to increase this RPM so it goes a little faster. And I can click start. And we go to this camera here. You can see it's moving around, but it's not drawing anything yet. And that's because the pen is not on the paper here. But what I can do is I have movement distance here, and I have my controls. I can just click in, and it'll move in now 1 millimeter. And as it does that, if we go back, I think you'll be able to see it showing up here. It actually is drawing that pattern on the paper now. And so, again, this doesn't have to be a pen. This could be a cutter of different varieties that you have in the router or in other different ways. So now it'll just keep going around and around and around like this. But I can stop this, and when I click stop, it's going to back it off, and it's going to move it right back to our 0 position. Because one of the things that you do with ornamental turning is that you'll do phasing. So now maybe I want to actually rotate this a little bit and then do the same pattern again. So if I say, I'm going to rotate this, I'm just going to do this kind of arbitrarily, 30 degrees. I can move that 30 degrees. I can click start again. And I can drive it in again. And now we're cutting 30 degrees off of the last one that we did, or drawing in this case, not cutting. But this can give you very interesting patterns. You can see we're kind of doing a double helix type pattern in this case.
So instead of doing off center with the axis of the spindle, you're doing, you can do offset pendants and things of that nature just by using.
You can do offset. If I'm understanding your question correctly. So the question was about doing things that are offset. So offset of the spindle axis. Yeah, you can do that. I'll show you what that looks like here. And I should say that, again, this is the one that I lost a lot of sleep over because I was trying to figure out a whole bunch of things. But if I use this eccentric offset here, and I put some value in here, if I say, I have to actually reload the file in order for this to work, but you can kind of see what happens. It will do that now. You can see that my radius has increased to 35. So I would have to, if I wanted to get this exactly as it is, I would have to go to 35 now. And if I start that, and so now it will make that correct pattern, but it's going to be offset from the spindle axis by 10 millimeters. So there are lots of different things that you can do with this. And the patterns that you have for doing this are, again, limitless in the sense that you can draw whatever you want. So you can do, these are all very, standards. Oops, let me get rid of that offset for now. The F4 rosette, this floral rosette is a, standard ones. They have all these designations in the ornamental turning world, and there's a lot of words that I still don't understand when they say them, but I'm learning slowly and trying to incorporate those things here. One thing is that quite often you don't want to do any sort of funky thing in the sense that you want to draw something. You just want to do a sine wave, or you want to do a square wave. So I have the ability to, not very flat, to do periodic wave functions. So you can say, okay, I want to do a sine wave, and I want the amplitude for this to be 3 millimeters, and I want to do 20 periods. And then we can create that rosette, and that's going to be our sine wave. And we could put that in. Or we could say, okay, I want to do a sawtooth pattern and create that. And so you could do a sawtooth. And so you've got lots of different ways to do this. Now, this is sort of half of it, because this would be the rocking. But the other thing that you can do with ornamental lathes is you can do what's called pumping. So pumping would be when you're moving this direction, because in that case, the actual spindle moves in and out like this. And so we have the ability to do that with this machine, and you can do them simultaneously. So that's much harder to do on a mechanical rose engine. And this is an example of some of the things that you can do on the side there. The top there I'll be getting to in a minute. But, and these are other examples of doing things where you can do simultaneous rocking and pumping and do patterns on boxes. I'm not much of a box maker, but I've been having fun exploring doing some of those types of things. Everybody does like spirographs, or we used to. This is in the ornamental turning world. Yeah, it's not a very good box. Is what's called a geometric chuck. So you do geometric designs, and you can put in, there are different stages. So in this case, for a geometric chuck, you'd have a whole bunch of stages, and depending on the gear ratios that you have, that basically is like a spirograph, right? If you think about how you make a spirograph. And so you have all the options that you can put that information in here with the radii, or you can click the random button, which I like to do a lot more. And when you do that, it'll give you random patterns using that. So my screen's a little bit big here, but all right, that it gets a little bit busy. But these are all things that if you just click random, you can get patterns that look like this. You can also save those patterns. So here's, I don't know, this is one that I've saved here. And you can also say, in this case, this has a very large radius at 80 millimeters. But I don't want it to be 80 millimeters. I want it to be wherever I am now, which is 35 millimeters. So I could say, okay, the target radius for this is 35 millimeters. I click create, and now that sets that radius at 35 millimeters. And I can do the same thing. This one will take a while to do. I probably won't do the whole thing. but I just click start, and then I drive that in. Obviously need to drive that in just a little bit more. My paper is not.
Now is this cutting on some flat work?
This would be cutting on flat work, so on a box lid or something like that. I think I have a pattern like that on that one. It can do a variety of other things as well that you can make it. I was testing with that one. You can tell it to cut deeper at the interior or the exterior so that you're not actually cutting a consistent depth all the way through, so it actually changes depth as you're making cuts. So it's a variety of different things. I probably shouldn't have brought that box. You can also, this one will go on a while. I probably should have picked a different one because it's a large pattern. But you can convert things from being purely round patterns. They don't have to be round. And if you're into ornamental turning, you might pay another $1,000 and buy an elliptical chuck so that it'll take your patterns and rather than make them round, it'll make them ellipses. And we can do that quite simply here. I'll just go back to this F4 rosette. Oops. Or, yeah, we'll do the F4 rosette. No, that doesn't look very good, elliptical. We'll do this one. Close the geometric chuck. And we can open up the elliptical chuck and we can give it a nominal radius and we just give it some ratio. And if we give it some ratio here when we start this, rather than being round now, it's actually made it an ellipse. And did I hand that? Oh no, here. And you can use that to cut an ellipse. This started as a circle. And now I can just move the cutter along, progress the cutter this way, and it'll cut that. And you can even, in some more complex cases, you can get it to follow the profile. So you can, like we did with the scan with the probe, I could scan this ellipse, and then I could say that I want it to, as we're going around, I could pump along the elliptical shape. So, and you can also hook the laser up. So on the top of that one, you can see you can actually burn with the laser those patterns in there. So yeah. Okay. I don't want to, take up too much more of your time. There's a lot of other things that it can do. It just takes a while to describe those, but I'd be very, very happy to answer any additional questions that you have about this, or if you want insight into any particular thing to go more in depth on a particular topic. Anyone?
When you buy the kit, when you buy it as a kit, everything's pre-drilled and everything, or do you actually drill the holes?
Everything's pre-drilled. It's nut and bolt assembly. So, there's a few things where putting the linear rails on, there's, I have 3D printed spacers that you put in to make sure that you get the rails spaced as well as possible. Use some clamps to kind of help you with a few of those things, but otherwise it's just straight nut and bolt assembly.
And then the software you would load onto a laptop?
Yeah, the software will run on any operating system. So I use Linux as my main operating system, but it'll run on Windows. I've got an installer for Windows, so it'll install all the software in one go. It actually, you'll notice it's a web browser. So it's not connected to the internet in any way, but it runs as a web server on whatever computer you install it on. And it runs in the background. So you just connect a web browser up, and then you have control over all of the software. What's that?
You don't have to vent that like you do a laser.
You don't have to vent it unless you're using a laser on it. And in that case, yeah, you've got issues with with fumes.
How long did it take you to learn how to do that?
Well, I think I'm still learning. So, but I've been working on this project for just over 3 years now. So from the point that I said, you know, I think I'm ready to play with this a little more in depth. And it turned out it was serendipity was at work, because a member of our club had just quit turning because he had Parkinson's, and he said, if you can get my lathe out of my garage, you can have it. So I got a stubby 750 for free. And I got that thing home, and I was looking at it, and it has M10 tapped holes all over the whole thing. And I was thinking, well, I could really bolt a whole bunch of things onto this lathe now, and that got me thinking again about doing this kind of project, and I went from there, so.
Is there a pre-assembled option?
There is. The pre-assembled option, I think, is about like $400 more, because. Yeah. So I don't remember the exact numbers on it, but it's something along those lines, because it takes me a couple hours to put it together. So.
Is it all metal? Or
It's aluminum extrusion. So the linear rails here and the carriage, these are all aluminum pieces. There are some 3D printed pieces. The pulleys are 3D printed, because that would just cost way too much to manufacture any other way. There are a few other 3D printed parts. The case for the electronics is 3D printed. I have, underneath this B-axis, I have a couple of 3D printed parts that act as skids, just to provide additional support when you're making heavy cuts in this. But yeah, everything else it's close to off-the-shelf parts that you can buy. It's designed, the original kits that I made were designed off of the open builds. This is the C-beam extrusion that they have, and they have sort of a whole setup for that. I wanted to go with the linear rails to provide rigidity, and so I had to have a custom carriage set up for that. So I had all that designed and made for the kits that I have.
what size of lead screws do you use?
It's 40-80. So there's always a hard question. So as far as extrusion, do you mean the
Threads on what the thickness of the lead screws themselves?
The lead screws are 8mm lead screws. Yeah, 8mm lead screws.
So what do you teach?
I teach biochemistry. So yeah, this.
Gets into more structural engineering.
Well, yes. This is my release when I get tired of undergraduates. No, I like teaching undergraduates, but yeah. I gotta have something to do when I come home. So doing some wood turning and then throwing something on here. It's always nice to have outlets.
It's very interesting.
Thank you. If you want to get in touch with me, I got a few cards here. If people has an email address on it that you can contact me if you want more questions. You can just set them on the chair if people want to take them. Happy to answer. I don't know if anybody uses Discord, but I have a Discord server where almost all of the users of the machine congregate and ask questions and share insights into what they've come across. What's that?
Just Discord server on the phone.
It's on the website. If you find it if you go to the website.
How many users do you have out there?
There's 20-something people that have them. I don't know, like strong active users, maybe in the 10-ish range. A number of people have bought them and kind of run into issues. And I provide all the support that I can, but then they just kind of decide, okay, not for me, so. All right.
Questions?